Ants on a stick, problem number 3 from round C of Kickstart 2022. And this problem states that a girl named Ada has n ants labeled from 1 to n, and she decides to test John's concentration skills. And basically, there is a stick that is L centimeter long, and she drops ants on it, and each ant has a position pi and a direction di. And when the ants fall, they land on the position pi and they start moving in the direction they are given. And all of them move with the same speed, that is 1 centimeter per second. Yeah. And when two ants meet, they bounce off each other and reverse their directions. And when they reach either end of it, they fall. So now Ada wants John to find the order in which the ants fall off the stick. Okay, so let's take the input. Where n is the number of ants and the positions, the number of positions, and the ith line contains two integers p of I and d of I, the position and the direction of ant I. Okay, and L is the length of the stick. Right. So the n lengths. So we have to take two vectors, I guess, or arrays, whatever we call them. So one would be p, should be n comma 0, and d, this should also be n comma 0. And I'm just going to cn p of I and d of I. So I'm thinking we can simulate it maybe. So let's consider some cases first, and we have to print the answer like case number x. X is the test case number and A is the label of the ith fan falls of the stick, otherwise first ant to fall of the stick. Okay, so we already know that the ants that will fall from the stick are the cornermost ones, right? Either this one will fall or this one will fall. Either one of these would fall. That is for sure. We're gonna keep this observation in mind. This is the number 1 observation. Second observation, let's take two ants. So if the direction of the first ant is towards the right and the direction of the right ant is towards the left, that means this has a direction of 1 and this has a direction of 0, and the I is less than j, right? Then these ants are moving towards each other and they will bounce after 0.5 seconds, right? So this is the second observation. And in any other case where these can be any ij, and so any ij like this, I less than j, and where this combination can be 0 0 or 0 1 or 1 1. So in all of these cases the ants would not touch into each other, because let's say this is moving with one velocity towards the right and this is also moving with one velocity towards the right, then they won't ever like crash into each other. And also these are moving in the opposite direction, so they won't also crash. This is another observation. And the last observation is that can we simulate it? Let's see, can we simulate it? Can we just like go on increasing time by 0.5 seconds, because each jump or each bounce will happen in minimum of 0.5 seconds, because pi is integer, I guess. Pi is integer, and since the minimum distance they can have is 1 between them, and if both of them are going towards each other, then the minimum time in which one would bounce will be 0.5 seconds. And I think we can solve test set 1 for sure in that simulation, I guess. So n is less than L, so n is less than the length of the stick, of course. 0,1 and 0 से बड़े हैं P of I, और L से छोटा है, मतलब कॉर्नर पे नहीं है. Okay, so it's like from 1 to n minus 1. So this ant also has a distance of 1 from here. This ant also has a distance of 1. Oh wait. If pi is the position, okay, pi centimeter away from the left end. That means if pi is not equal to 0, never equal to 0, it is equal to 1. That means it is a distance 1 from the left. Okay, that is understandable. Now let's take the input. Now the main problem arises, how to solve this. So n is 1, L is 5. If there is only 1, then we can safely say that 1 will fall. And the next scenario, this is the position. And now the n and L. So there are 2 ants and the length of the stick is 7. First ant is placed at 4 and going into the right direction. Second ant is at position 5 and going in the left direction. So this is the perfect case for the bounce. So these will crash in 0.5 seconds and reverse their direction. Ant 2 then reaches the right end of the stick at 3 seconds, whereas ant 1 reaches. Now we also need to calculate their bounce position, and that would be not an integer coordinate. Let's look at sample case 3. As 2 and 4 move towards each other. Wait. 5 and length is 0. Oh no. So 4 and length is 10. So 1 is at 8 and 0. So moving towards left. So at 8 and moving towards left. And 2 and 1. So at 2 it is going towards right. And at 6 it's going to the right direction. So this is in the right direction. And 4 and 0, so this is going to the left. So this is somewhat the case. RL. So these two ants are gonna bump into each other, and these two are gonna bump into each other. And which one will be the first one to bump? 2 and 4 move towards each other and meet at 1 second. Similarly, 1 and 3 move together and meet at 1 second. Not 4 ants change their directions. 1 and 2 move. Okay. How do I simulate this? I thought I could only take care of the outermost ants, but that's not true because we have to keep track of these ants' position as well. So if L is up till 100 and N is 10, that is like of 1 then. So I can probably simulate this for test case 1. And to do that, what I'm gonna do is R while true, right? And now I'm gonna increase the time by 0.5 seconds. So let's say time is 0 currently. Right. Or let's consider this double. So time plus equals 0.5, and so what will be the position of each and every ant? That would be 4 so the p of I would change, would be equal to p of I plus if it is 0, so if it is 0 then I'll negate it, and if it's 1 then I'll add it. So I can say if d of I is equal 0, then I'm gonna subtract the time into the speed, that is 0.5, speed is 1, else I'm gonna say p of I minus, plus equals to 0.5. Right. Now what will happen is that some elements inside of this will have same coordinates, and for that I'm gonna say that if p of I, we can first sort it also. Wait, we cannot sort it because the position and the direction are linked. Are we given that in sorted order? I guess not, because we see this. And if I have to sort them, I'll have to take a pair of vector. What I can do is basically has to love, has to love. Can PI be same for two ants at the start? If not, then I can keep track of this pi in another variable. So I can like say a pause, and this can be a map. So at position I, how many ants are present at the position I, and I'm gonna do count pause of this plus plus. This is pretty weird, but I don't know. And this would be like this. And I'm just gonna check right here that if pulse of p of I is greater than 1, that means, oh, we have to check it later on, because there can be many ants that, no, there cannot be many ants that meet at the same position. There can only be 2 ants that meet at that location after 0.5 seconds. So ideally I can do it inside of this, but let's just do it outside. So for auto IT, I don't even know what this means, okay? So don't judge me on this one. So if it dot second is greater than 1, that means every ant having the position oh shit. Now how do I find which ants collided at that position? So I think I can create a canvas. Although since I'm just solving for the test case 1, I can just do a linear search for that position. But I can also create like something like int line or a vector, int, not int or int. Let's just do a linear search for, because we are just solving for the first exercise. So for int k is equal to 0, k less than n plus plus, if p of I is equals it dot first, then d of I, if d of I is 0, then d of I would be equal to 1, else d of I would be equals to 0, and if now if some guy goes outside the boundary of our L, that is if p of I is less than equal to 0, and or P of I is greater than N, greater than equal to N, right? Because yeah, I don't know, man. Then we can see out, right? Remove this I from the and now how am I gonna remove this I? I go from highs to low, low. I go from highs to low, low. Should have sorted it, man. Should have sorted it. Okay. Some bad decisions in the past. Just let it be. Just solve it somehow. Write bad code. Just do it. Bad decision on the data structure. Should have taken a vector of pair of int. But to remove this, what I can do is since I'm only moving 0.5, that means they will eventually be equal to 0 and equal to L at some point if they were at integer coordinates. Now floating point arithmetic might fuck up everything. So, and also this is int, right? So I can make it a double first of all, and how do I make this an integer? That's fucked up now, because if I move by 0.5, I can just multiply everything by 2 and it would be an integer. But it's too late now. Can I just do that, please? Okay. If pi minus 0 is less than epsilon, or pi minus L, an absolute value is less than epsilon, then I can safely remove this. And epsilon is basically what? Time limit exceeded. Nice. Okay, I'm not breaking it. So let's take an int count. Can we do a double here? Can we please? Compilation error doesn't show me what is the error. Why is it not showing case number 3? I could Oh, where is case number 3, my fellows? Where is case number 3? Please show me case number 3. Please. The hell? I go from highs to low. What? But why? Okay. Now please show me. केस 2 भी चला गया. You got me so hard, you got me so hard. सब लोगों की स्पीड डबल कर दी 0.5 सेकेंड ही बढ़ रहा है टाइम और अब वो 1 चल रहे हैं बजाय 0.5 चलने के स्पीड डबल करिए तो लेंथ भी डबल कर दी नीचे ये ये फर्क नहीं करेगा मेरे हिसाब से ये करेगा instead of this I can now write अगर एक से ज़्यादा बच्चे वहाँ हैं एक से ज़्यादा एंड्स वहाँ हैं तो उनकी डायरेक्शन बदल देनी चाहिए और क्या करना चाहिए कुछ भी नहीं और यहाँ पे लिखना चाहिए मुझे ये नहीं समझ आया कि ये क्यों आ रहा है 114 पे 1 ओह फक इसको 0 भी तो करना पड़ेगा मतलब मैप हर बार नया बनना चाहिए मेरे हिसाब से ठीक है ये अभी भी यही आ रहा है क्या हो रहा है इसका मतलब पहले मैप की वजह से ही प्रॉब्लम हो रही है इसके हिसाब से 3+1 पे गिरना पड़ेगा इसमें सारी वैल्यूज अरे और नीचे क्यों नहीं जा रहा है? One five is the length, and 1 is present at one position. One position going right. I just hope this works. Because if it doesn't, I'm gonna cry. I just want to pass the test case 1, and that's all I want from this code. Not like all I want is to clear test 1. I want to clear test case 2 also and 3 also, but at least this code passes test 1 at least, please. Okay, 5253. Come on, exceed time limit. Okay, so these would be skipped. So 20 seconds. So this would not be skipped. So I think we are getting an AC on test set 1. Edgar's new game is called Paranormal Deletions. As a player of this game, you are given a string of length n. You will perform the following process n times. Pick an index in the current string uniformly at random. Delete the character at the uniformly random. What does that mean? Delete the character at that index, you will then end up with a new string with one fewer character. If a new string is a palindrome, you eat a piece of candy in celebration. Start a string. What is the expected number of candies you will eat during the game? Expected number. and not like you want to maximize the number of candies you eat or something like that. X is the test case number. So if B is removed, A remains. 2 candies. This again 2 candies. Now you have to search every search position. Delete A, then B, then A, then A, then B, B, then A, then A. So 3 was then 3 factorial permutations, I guess. Test set 1 passed, and that is what I needed. Let's see the rank. Please increase drastically. Please. Oh, it did increase drastically, and I love that. I love it. Thanks. Trash code written by me, but still rank got increased. Okay. Now, is it worth it to try this again and do the better approach in which I maybe be able to do this one, if not this one? If I sort it, will I be able to do this one? Because this is like 10 points and this is like 14. Let's try this then. If I solve for what is the test case 1 in this, n is up till 8. Okay, so 8 factorial is like 8 factorial 40,000. 40,000 for each test case. That means test case are 20. That means 20 into 40,000. And that's not even what has been asked. So I'll go each test case and I'll divide it by that factorial, and in each test case, in each way, I'm going to calculate the number of palindromes, and that is going to take a lot of complexity. Palindrome using dynamic programming or something like that, in which if I'm deleting a single character, then if I want to check now is it a palindrome, I can check that quickly. I don't need to traverse that string all over again. Is there a way to do that? And why do we have to do a mod? Is E like a large value? Okay, expected number of candies would be a large value, but not for n equals to 8, I guess. Okay. Since n is 8, then these are like 8 factorial ways, and in each way I'm gonna check the string that will be of length 8. So O of 8 into 40,000, and that will also be checked 8 times. So 8 into 8, that is 64. So here there will come 8 strings, 8 or 9 if I include this one, and I'll check that if this is a palindrome. So let's do this. Oh shit. What is this? Oh, now I see I would need a modulo. Okay. Expectations. Fermat's little theorem. I don't know, modular inverse calculation, and whatever they have done right here goes above my head always. Uniquely determined number. What does that mean? So is it all done because we want an integer? Then why don't we just... Okay, there is no better way than modular. So this one is a bit more difficult. So I guess I'll have to settle in on this score. I'm really like, it's fine, it's decent. Could have been better, but I'm just gonna go now. GG's.